Thank you for coming today. I am here to convince you that GCC is an amazing piece of software that suffers from a lack of documentation and can be made even better than it is. We set out to add COBOL to GCC a couple of years ago. We're doing that because GCC is the only way you can do it. I'll explain. And because we really need a free COBOL compiler to free, some people, hundreds of billions of lines of COBOL from mainframe environments, safe to say. If you're a bank, if you're a railroad, if you're an insurance company, you are running COBOL. If you used an ATM this morning, your money ran through a COBOL application that was written in 1975, give or take a couple decades. That software is, okay, for decades, everybody wrote their stuff in COBOL. Then we went through many other changes, as you know, and a lot of those COBOL applications either became obsolete or were converted to Java, and what's left cannot be either one. It's important. It's one big pile of mashed spaghetti that's fossilized. It's not well designed, but it can be recompiled. It can be run on other systems. And that's a good thing because the systems they're running on today don't exist. The systems they're running on today are emulations of hardware that IBM hasn't made for 30 to 30 years. They're efficient because they had to be, because they were very small machines they were running on at the time. By today's standards, you know, there's no problem in running this software. But it is ensconced in a very highly proprietary environment. Everything from the editor to the you know, what you might think of as the build system or the runtime system, all of that stuff. Everything is a proprietary environment. So if we take this thing out, we can put it into a free environment and make it malleable again. You don't have to change the code. You just have to put it someplace where you can run it. So that's our business plan, to build a simple compiler, simple I'll say, ISO standard COBOL compiler that then may need to be tailored to individual situations. We think if we can write the compiler, we can probably do the tailoring too. COBOL is a gigantic language. And I think these numbers make it clear. I want to point out just for the moment that the ISO COBOL document that describes the language is 1,200 pages. It's a significant number we'll come to in a little bit. One of the reasons it's big is that it incorporates the I/O, where in C, I/O is a library call. In COBOL, I/O is defined by the compiler, by the program. And so are I/O exceptions and other kinds of exceptions defined by the compiler. So things that we think of as runtime responsibilities or stuff that happens in the operating system have defined effects in your COBOL application if you want them to be. In the old days, they weren't. That stuff got added, and if your program doesn't include them, you don't get it. So my boss came to me and said, we should build a compiler. And I said, are you crazy? And luckily, we were both a little bit nuts. GCC already exists and provides a framework so that I don't have to build a compiler. I just have to add to one that's already there. So GCC began as a C compiler, one language. And they did something that I don't think has been done anywhere else. They said, oh, we'll make many languages out of it. So from your perspective, there's your compiler. It's as simple as that. You've got input, you have output. Who you are in that grid depends on which language you're talking about. Because GCC said, we have some number of machines we're going to produce code that runs. We have some number of languages we're going to accept input from, and we can mix and match those things. You can take your C code, your Java code, your Go code. You can run it on an ARM machine or an Intel machine. Just put it together how you like. Each developer, I think, tends to see GCC through one particular lens, whatever language they happen to use. So we set about adding to this thing. And we learned a few things. Well, so let me explain what that simple box, what this one, looks like to us. The system so GCOBOL is just what they call a compiler driver. It's a thing that accepts a whole bunch of options. You tell it what you want to take in and take out, and it produces what you ask for. It does that by invoking different processes. So GCOBOL is an executable. It invokes an executable, COBOL 1. That's an actual compiler. That's the thing that reads the input and produces assembler code. Then we invoke the assembler. Then we invoke the linker. Then you get something. So we had to figure out how to plug our ideas about this, how to make this thing useful exist inside the GCC framework. I wanted to talk about what the compiler itself looks like. Again, the COBOL 1 compiler, COBOL 1 it's called, COBOL 1 compiler, is taking in whatever command line options you provided it with, so it knows what files to read, knows where to go. It has to assemble, I shouldn't call it that, but it has to incorporate all the various input files into one single stream that is going to be parsed. Goes through a parser, we build ourselves a symbol table, and eventually, between myself and my colleague, we generate what GCC calls generic. And generic is, I will argue, the assembly language of the internals of GCC. That's what I would call it. And then things get a little murky, which I'll talk about in a moment. But this is all we had to do, you could say. We just had to accept the COBOL, 1,200 pages of documentation for what that's supposed to look like, and spit out generic code that the rest of the compiler will assemble for us. Hooray. It's all written down. There's even a GCC internals document. It's like 80 pages long. So from there, it's a little harder for me to explain exactly what happens. I'll take my shot. But to me, the back end of the compiler is very much a black box. That's partly my fault, because I do the parsing. And it's partly not my fault, because it's not all written down. But here's one man's understanding of what this looks like. And I want you to be very happy you're here today, because this diagram doesn't appear in their documentation. Which means it might be right, or close. So we take generic, and generic goes through a thing they call the gimplifier, because originally, I don't know if there is an original in GCC, but we'll say originally, there was no generic. There was a thing called Gimple, which was maybe the proto-assembly language of the internals of GCC. So it's gimplified, and then it passes through upwards of 100 passes to convert it from that internal tree, that internal language, internal construction, into various simpler and simpler things until I think it is the control flow graph system produces the assembler code. What that thing called intermediate representation actually looks like inside the system changes as the process goes along. And but I cannot say that I understand it, because if you read the GCC internals document, it won't tell you the things you need to know to do that. My colleague, who was supposed to give this part of the talk coming up, just said, look, just tell them it's not documented. That would be the closest thing to true. So I had the easy part. COBOL is a documented language. It predates Bacchus-Naur, by the way, so it's not exactly designed to be parsed. But nevertheless, it has a definition. And I use tools that are also very well documented. Flex and Bison are based on well understood computer science theory, and they have good documentation. I had some qualms with their documentation, but I've been able to use their tools to do what needs to be done. Then all I do is say, okay, here's a big parse. Here's all the things that went into the parse. Here, Bob. go make this into generic. And he says, okay, how do I do that? And that is a mystery because generic has a defined set of nodes. It's a tree in memory, but it doesn't have a defined grammar, I'm going to say. There are references in the GCC documentation to various kinds of computer science theory, like static single addresses assignment. But exactly what the relationship is between those different phases that I showed you a moment ago and those textbook ideas is not explicated anywhere. So what we did was we said, okay, how do we do this? We took an example on the internet, because that's the only way you can. A man who had a 7-part series on how to add a language to GCC and said, okay, let me see if we can do that. Bob told me last week, he said, yeah, that was helpful, but he was wrong. So it took us about a week. So you can actually just, you clone GCC and you say, okay, these different parts, and it says I have to have a thing for COBOL over here and a thing for COBOL over there. And there are these sort of callbacks and macros and things, and you say all the pieces you want, and you define a directory where it's all going to go, and poof, you have a prototype, a thing that works a little bit. And the distance from there to here has been the better part of 4 years. We are now at a point where our compiler passes this NIST standard test for COBOL for 1985, not nothing. We implement most of the features that are described by ISO 2023, so we feel like we're getting to be up to date. There are still things that are missing, and I don't know. There might be another 7 man-years left in it. We'll have to see how much. We expect what will happen is, as has already happened with people who've begun using it, they come back and say, we need this feature, we need that feature, we need another feature. So you extend it in different ways, or fix things that were wrong in some cases. I wanted to point this, I put this quote in here to point out something. What we're doing should be impossible, or at least really, really hard, because let's say for sure, GCC's whole theory contradicts this, what the man says in his engineering textbook should be true. We're going to say, oh, all of that back end? That's independent of all the front end. And all that stuff you're producing, it doesn't matter what applications you're running on. That's GCC's theory, and that's not what the textbooks say. One of our challenges in adding to GCC was that it started out as a C compiler, and it still sort of is. So an example of that I wanted to put was that COBOL has a thing called perform, because it has things called paragraphs, and paragraphs are not functions. Paragraphs are labels in the middle of your code that you can run through. Just imagine an assembly code that has labels. And then perform means go to that label, and when you get to the end of that thing that's been qualified by that label, or some other label later on, come back to me. We did implement it as a call, and it can't be done. There were reasons not. I wish he was here to explain why, but it's one of the things. There is a call. You can call things, but perform is not call. When you perform a paragraph, it doesn't have call characteristics. It has call characteristics, but it's not good enough. Yeah.
It shares the same stack?
Yep. Yep, although there's hardly any stack.
Are there any stacks? I'm sorry.
It's a lonely job. If you want to write a compiler, be prepared to sit alone a lot of the time. And when you find you have a problem, be prepared to be completely alone with that problem, because nobody else has your problem. When you write to the Bison list and you say, why doesn't this work? They'll say, there are books you can read about that. So it is a good way to work all by yourself, which is fine with me, but you just want to know that's the story. Bob pointed out, my colleague pointed out, that we're 36 years into GCC, and we're going to be the 12th language. So every few years, somebody comes along and adds a parser to GCC. By the time we got there, there are only a couple of guys left who are still doing it. So there just isn't a big body of knowledge about how to do this. And one of the things that happens is you get to the end, and maybe you've had your experience yourself. You get to the end of something, and you say, now I know how to do that. Maybe I should write that down for the next guy who comes along. but nobody's paying you to do that, so it doesn't get done. So I think that's part of the reason. It's just hard and it's sparse, and there isn't much motive, much incentive to go out and produce the kind of documentation that's really needed. I told you a little bit ago that the COBOL definition is 1,280 pages. The language we're writing to is every bit as complex, I would argue, and it's documented with about 80 pages. They say it's preliminary. I beg your pardon, did you just say something?
I'm sorry. Is there an inherent reason COBOL is more difficult than some of the other older languages that are in the GCC? I believe Fortran is, maybe Modula,
So not Fortran, yes. Fortran is in the same category. Languages since Algol 60 tend to have a definition expressed in Bacchus-Nauer format. That makes them, I'll say, parsable, right, with a context-free parser. For a parser for a context-free language. COBOL has features, we are using such a parser, but there were things we had to do to really shim that in, because there's stuff. As an example, the if statement has no then. Rather, it could have a then, but it doesn't have to have a then. And as it turns out, that makes, if then is a classical example in languages like Yak for a thing that can be hard to parse, and there are ways to do it, but the then is really important.
Yeah.
Yep. It's.
I'm 20 years since I've close to trying to go parser at Georgia Tech class like level. So I don't want to insult anything. Can you multi-pass it to solve some of that? Like if something's less actively optional, or does that change the meaning?
I really cannot. At least the tool that I use, once you've got to a place, you have to be there. You can't say, oh, that's too late. I have to go back and start parsing a new stream of tokens. It's actually not a possibility. I don't want to run out of time, though, so I'm going to keep going. So as I said, I don't think there's a lot of commercial incentive to document the internals of GCC. But I think there's a huge open source reason to do it. And it is that GCC is possibly the indispensable tool that we have in our whole suite. I'm not sure where else you would go. I don't know of another compiler that does what it does. But you'd be amazed what is missing once you start looking for things you need to know. I use the term compiler driver for what we call GCOBOL. That term doesn't appear in the main GCC documentation. Internally, we were encouraged to begin because there is an internal GCC document. And it does give you a kind of glossary to understand what to look for as you're trying to decode what's going on inside the system. But that's all you get. And it's not only me saying this. They admit it. Rather, they document it. They say, this is preliminary documentation. That statement hasn't changed in the 4 years I've been involved. And I think that statement was made 10 years ago. So this is just a count of the terms bug and to do and fix me that appear in that document today, or the last time I pulled the tree. So we did the work. I had the benefit of standard tools, documented. We know how to work with them. I'd never written a compiler before, but I could read how to do it. I gave to Bob the problem of how do you generate the generic, and the answer to that was see how somebody else did it. So our basic technique is write a tiny little piece of C, splat out a giant set of dumps, take a look at what they did, and try to guess how you would do that yourself. It's not an ideal way. To do this, Bob wrote an HTML dumper, so you get pretty good representation of the generic tree in HTML form. And it's kind of nice because you can click on, he put links in so you can move around in it. And when he offered that as a patch to GCC, sadly, they said, well, JSON would be better. So he did it in JSON because that was what they wanted. And they didn't like to take that either. We're still using what we have. But I'm going to say that neither of those is the right idea, and I'm hoping to convince you that I'm right about that. I think the solution to documenting GCC's internals is a combination of money from without and a language to do it with. I think the problem with simply using dumps as a way, so here you are, you create this tree inside your compiler, and you say, splat that all out in HTML or JSON form, and let me look and see what they did, so I can go off and do it this way. I think it's really important that that dump be itself a compilable thing, so you can test it, so you can prove it's really what it is. Is it in fact true that this dump represents what came out of the front end? Maybe. But if you could compile it and it produced the same object code, you would know for sure it was doing the right thing. So I think that's necessary. Also, if we had a standard textual representation for the internals of the compiler, we would be able to get better communication between different parts of the compiler, like the guy that wrote the Fortran front end and me. I would like to be able to, so large COBOL compilers today have Ginny interfaces to Java systems. GCC, you'll remember, is one system. If it's one system, it can have one internal representation for all of its languages. In fact, it has that inside the compilation. If there was better documentation for how that was done, I would know how to represent C++ objects in COBOL objects. COBOL got objects about 20 years ago, so we could have interoperability, and we'd be the first compiler on the planet to do that if we did it. But I don't have a good way to understand what they're doing, and they can't see what I'm doing either. And that's just objects. Another thing that I bumped into, or we've bumped into, is that there are, maybe I'll get to that in a different slide. So I suggest that Lisp would be a good representation for generic trees. Lisp, we know how to compile Lisp. Lisp has a good way of an old, long, well-understood way of representing trees. So I've been saying to people who agree with me that that should be the dump language, and that we should write a front end for Lisp that would produce generic. So you could take the dump, you could compile it, you could compare it. This is what I think we should be doing. I think it would be a much simpler Lisp than Common Lisp, actually. But you could. There's nothing to stop you once you start. It does. Well, right. First of all, Lisp has almost no syntax. That's a good thing when you're trying to do something simple. Also, you might not know it, but I think it's a good likelihood your editor has support for Lisp already. So if you want to jump to the definition of the thing, if you want to compare two things, it's all set up for this sort of thing. Lisp even has standard ways of inserting documentation into the language. So that's why I think Lisp itself is a good answer. Also, you need a way to wrestle with generics complexity. This tiny little one line of C produces 56 generic nodes. Nobody is going to sit down. The reason Bob hates this idea is he said nobody's going to sit down and write 56 generic nodes for one line of C code. There's no way this tiny little C program, which produces 5,000 nodes, nobody's ever going to touch it. You can't do it. He's right. But Lisp macros could do it. The interpreter could do it. And then, so your representation would be much, much simpler. You would, you wouldn't write it in C, you would write it in Lisp, and you would get this little thing, and then you would use tooling to find the nodes that were either the interpreter itself would tell you where they were, or you would get a dump. There's lots of different ways. The language, you could have a library that has certain things that collect together, groups of these nodes. So I don't know any compiler other than GCC that has this front-end, back-end architecture. I don't know any other system I've ever touched that's more important than GCC is. I don't think we could do what we do in our environment today without GCC. So it's worth supporting, and it's already an amazing technology. And the reason the documentation is insufficient is because it's so complex, and because there's nobody whose job it is to make it documented. So Russia, if you're listening, the Linux Foundation, if you're listening, we could use money. We need a guy assigned to write the 3-volume set that will document this very important tool and help other people with my job to add other languages and make GCC more extensible, more effective, and also help GCC's own authors, right? The people working on it, see the internals of their own system and compare the outputs of different front ends and make them more compatible and more interoperable. Today, that just doesn't happen. So I said it's important. I think it deserves documentation. I think it deserves foundation support for that documentation. And I think that the generic assembler would bring us a thing that doesn't exist anywhere. We already have a system that is unique, but I don't know of any compiler that's ever tried to document its internal representation and make that directly accessible to the outside world in an external format. I don't think it's ever been done. I don't see why it couldn't be done, and I just think it would be an amazing result. So that's been our experience with GCC. I thank you very much for your time. You were first.
You said your manager kind of said, hey, let's do something crazy. Did he tell you why?
Yeah, oh yeah. It was there at the beginning of the slides. The fellow who started Symas Corporation used to work for IBM back in the day. He likes to tell you that he had to keep 2 suits in the closet at work in case that night they were sending him to Germany. So he left IBM, I'm going to guess around when Gerstner came in charge, when IBM started to think it was a services company and not a software company. I think that was about when. And he knew this COBOL thing was a business opportunity that nobody was really tackling effectively. There are COBOL compilers outside of IBM, there always were. There's one other free project that we were part of for a while before we decided to try and do it this way. But except for GNU COBOL, which is the one I'm talking about, except for that one, they're all proprietary, they're all expensive, and they're all kind of weird. So if you've ever used a weird compiler, you know what I mean. It's hard, it doesn't fit into the environment you've got already. You're not going to run it in the cloud. So he said, if we can just get this thing off the ground, money will just pour in over the wall. We won't know what to do with it all if we can only make the thing work. So he said, let's try and make it work. And I said, all right. I don't know how to write a compiler, but you know, I can learn. So that's what that was the business plan is, make something standard that the free community can use and enhance, that belongs to the customers themselves. But if you have but your special COBOL may need some special alterations, and we'll make that available to you. Well, that'll become upstream, right? We have no interest in our own compiler. All we want to do is make money making compilers, because then we can sell other software into that. That's the business proposition. I tell people I'm 4 years into a 10-year plan, so I'm not retiring until then.
So, I forgot. Oh, I'm shocked that the generic assembler is not done. I would actually was half-heartedly look for it.
So the internals of
But now I know I'm looking for something.
the internals of GCC are the entire internals of GCC. 300,000 lines of code, 16,000 files are documented with 800 pages. Not nothing. But it really wants a 3-volume set, or maybe a 4-volume set, right? And the generic is documented to the extent that each node has a name and a definition and a structure. And sometimes it tells you what other nodes are part of that node. There is no system that verifies the internal correctness of that. None at all. Well, there is. If you do it wrong, your code just dies. Your compiler just falls over. Because the type system in C is not, because the types that are in generic are not part of the C type system, there's no compiler that verifies any of that stuff. right? It is verified by virtue of the fact that if it doesn't produce code, it doesn't work. But there's no syntactical connection, no analysis of it. So you can learn that there is a, for example, there's a generic node that defines the type of a function. And then that thing takes the function definition, and a function definition takes a list of function arguments, and function arguments take a list of statements that go inside. That's all written down. But that's very different from a syntax that you can understand. And there's a whole lot of missing pieces. I mean, it's now at the point, it's long been the point, but past the point where Bob says, gee, I don't know how this works. And I start reading the document to see, well, have you done this, that, and the other? It's just, seriously. You know, you're going to read a first grade primer to me to explain how it's not there. I promise you, I've been over that document. So it's, as GCC themselves say, it's preliminary. I found misspellings in the document that have stood there for 4 years. Maybe I'll send a patch. But it's just not ready. Yes?
You're with the bug bounty, right?
Yes.
You ever thought about a documentation bounty?
I have not, but I do intend to carry out my threat today. I'm going to talk to the foundations like FSF and the Linux Foundation, who say they are supporting our environment and who say they want to support the ecosystem that we live in, to suggest to them documentation of the internals of GCC would be an important, contribution to our world. Yeah.
For funding, I'm sure they have some of this stuff.
Yeah. I think it's difficult, right? Because how do you know you got a good product from that guy you asked to write the documentation? But I think GCC we could overlay that on the whole development process. Yes.
So I guess I have a counter question, which is, and you hinted at some past efforts that people spent time, rejected. I think GCC maintainers have a right to reject things.
Absolutely.
However, from the point of view of a funder, don't really want to spend a lot of effort on something that's going to get rejected. What can be done to increase the likelihood of acceptance at the end? And part of that, I'm sure, is incremental change. Because that's all we need. Anything beyond that.
I didn't pay him to ask that question, but I'm really glad you did.
Okay. I work for the Linux Foundation.
Oh, right. So this would be my answer to you. When Marty suggested to me that we should write this compiler, at some point in this development process, I got into quite a battle with my own company over whether this was going to be a full-fledged, absolutely free software FSF license or something else. Because there were people within the firm who were not sure that that was the best way to make money off of this. And I said to them, first of all, if you don't have me, I'm not doing it if that's not how it's going. I actually did tell them that. But I said, it doesn't matter whether you have me or not, because unless it's a GCC product with their imprimatur on it, it's not going to be accepted. You won't have the credibility. And how do I know? Because GNU COBOL doesn't have more than a half a dozen users, right, clients. So don't fail. Give it to them, make sure. So then I go to GCC and I said, we're writing a compiler. Wouldn't you like to be part of this? And they're like, that took a year. So the steering committee agreed to accept our work. So they said, we will include COBOL as one of the languages the GCC compiles. We think this is a worthy effort. I don't think it's the first time it did, and they didn't do it for me. I found evidence on the internet of a COBOL project for GCC from 10 years ago that never saw the light of day or never came to fruition. So first you get acceptance. Then there's a process. My code doesn't automatically get dumped in. I promise you that. But if I meet their terms, it does go in because the steering committee said it goes in. I think the documentation process should go through a similar thing. I would be astonished if the GCC steering committee said, nah, we don't really need documentation. I don't think that would happen. And what I think would happen is, as the book is written, let's call it, the same process that incorporates the patches that I send in order to put in the front end, the patch list gets hundreds of messages. Definitely maybe 1,000 messages a week, right? But some days, hundreds of messages. So it's a very active development system. I'd be amazed if people didn't scrutinize the documentation just as closely and watch it get built up and criticize it and say, no, this thing that you wrote, that's not accurate. Or you're using contradictory terminology or anyone else, right? But like build up the whole thing and then throw it out the back at the end? That's not going to happen because it has to be incorporated layer by layer. That would be my answer to you. I don't think every project is a good candidate for this. Not every project is important, probably no more important, but not every project is as well managed. But I think those would be criteria. And I would say to the steering committee, don't accept this if you're not going to review the work as it's going on, because otherwise it's going to fail. And you don't want a bad document. There's no point. Have I answered every last question? Thank you so much for coming in. Oh, yes.
Hopefully. Did you ever have a just real awkward, funny experience while you were working on the implementation details? Just a weird bug that you had to laugh about afterward?
Yes. Now you want me to tell you what it was. We've made so many mistakes. We're still wrestling with a big one. I alluded to it earlier, and we don't know what to do yet. C is made up of functions. I don't think there's any dispute about that, right?
Yes.
Functions, definitely. And not really big functions usually. 800 lines of functions maybe. Like, that's a big function. The whole COBOL program is one function, literally. There's only one call. That's the call to the top of the program. I'm lying a little bit. You can actually write COBOL programs with more than one place to come in, but basically one call. It's not uncommon for that program to be 400,000 lines of COBOL. I mean that literally. Not only because we've been doing it since 1961 or something. It's cheaper to add the, yep. And it's been around for so long that there are tools that generate COBOL from some definition file. So you've got some giant table, and you run it over this thing, and it produces this huge thing of COBOL, and off it goes. So I've got to compile, literally 800,000 lines of code, one function. And the performance sometimes stinks. There have been limitations inside the code generator that we think are implicit in the assumption that you're going to be writing C. And I'm not frustrated by that. I think what's going to happen is we're going to surface those issues as we go through the incorporation process, which we're in the beginning of. And they'll figure out what that statement the gentleman makes about needing to know all the pieces in order to know whether it's going to work. Well, we're just adding light to that fire. We're going to make that more apparent. And we'll figure out what the answer is. I don't know what it's going to be because I hardly understand it to begin with. But I think that's that. Yes. Yeah.
At the risk of making a baby question, because I don't write compilers regularly, and I've spent so much time in interpreted languages. As you're parsing down, and you encounter these scenarios like the procedural call that's not a function.
Mm-hmm. Perform, yeah.
When you mentioned Lisp, I was thinking Lisp is purely functional with no side effects. Yeah, okay, you got bang methods and stuff. It can't have side effects, but it can be done.
It's arguable, but okay.
Memory is cheap. What if for every branch you just generated out a method, even if it's duplicative, of the thing, and so, and then let the C-like the optimization layer on generic do its unrolling and things, whatever it does with its C languages. I have no idea if this would pass like test cases for the liquid fitness.
So I'm going to answer your question two different ways. One aspect of what you're talking about is actually a feature of Bison that I don't use. It has the ability to, while it's parsing, to try different parses. And then as each branch turns out not to be the right one, pick the right one. Those die off and one survives. That was too fancy for me, so I'm not using that feature. Maybe it would help in this if then else kind of thing. But in terms of the letting the optimizer optimize away the problems in the generic code, we're already at that boundary. By which I mean, we've had to make changes to our system to stacks because compilation time was too slow. It's still a challenge for us. I'm satisfied that we're about within 3 times the speed that we would like to be. But we're.
It's only like a COBOL system.
You would think. You would think. You would think. Compile time, once we, by the way, we parse COBOL just as fast as GNU COBOL does. They produce C code and translate it into, and pass that to GCC. We are producing generic directly, and they're beating us on compile time. Yes?
Interesting.
Yeah, just a comment from passing. When C++ and Ada were added specifically to what's now GCC.
Right, G++ was first, yep.
Right. There were changes made to the back end in particular.
To the back end?
To the back end. Specific, basically to all these things to support those languages. So it is not unknown to make changes. Oh wait, this language needs a new capability. It's okay. There's been quite a bit of historical precedence for making those changes. And so, oh wait, I need to treat this as a really, really large function and do that well. And frankly, that's probably a smaller change in some sense. Then it's more of an implementation issue than a radical new feature.
Right. It's not exception handling in C++, for example.
Exactly. Exactly. Or some of the other fun things that came along with the ride in these various systems. So I don't. It may be challenging to do, but it is certainly not unknown that I need that.
As I said, I'm optimistic. I think generic itself was invented for the same reason. And I think once we bring this in and we say, gee, that's a problem, and then we had to allocate our own set of static variables to avoid this stack that isn't working, and they'll be like, oh, all right, we can do that. I think that will happen.
Weak-like approach. So you had, so you're compiling it, you're going to generic. Certainly, if there's a dependency, generic could be pull requested. What if there is a very minimum, I hate to use the word virtual machine, but like helper library in your compiled code that somehow work with that representation to overcome some of that deficiency that's hard to represent. So overcome at runtime some of the deficiency that's hard to represent.
Excuse me.
At compile.
Am I taking your time? I'm very sorry. I should get out of your way.
No, if you want to keep talking out.
Of course, no, but I wasn't keeping track.
No, not at all. That's great.
Yeah.